Welcome to our second Tableau user group for this year. The first virtual one in a while. And I think so. Sort of the plan for me to go ahead is we will still run in-person user groups in Auckland. And then we'll run sort of maybe 2, maybe 3 virtual user groups a year. Because there's a bunch of people throughout the country that don't really have readily access to a user group. 2 of those present today. Steve in Dunedin and David out of Wellington, which used to have a user group, but that sort of died down a little bit with COVID. So we are sort of picking up the slack and trying to provide content for everybody in New Zealand and in other countries as well. So we have at least 2 people from Australia dialed in. And also to give the opportunity to people who are not based in Auckland to present to a larger audience and sort of present what they do on a daily basis with Tableau. With that, for everybody who doesn't know me, my name is Alex Waleczek. I'm the analytics practice lead at Merkle. I run the user group for, I think, 6 years now. And I'm quite happy that after COVID, we sort of built it up to a point where we are now with 25 people attending. The intro, I'll be basically after this slide. I think I'm done with my intro. After that, we have David Sharp from ANZ in Wellington presenting. He will be talking about continuous integration and continuous development for Tableau dashboards, which I think is quite interesting because typically people just sort of develop and then publish it to the server. So that's a good aspect of that many people are not aware of. And then we have Steve Wood from MTF Finance in Dunedin. Steve has been around the Tableau community for years. And is a Tableau ambassador. Well, he's with me. We are the 2 Tableau ambassadors in New Zealand, and he'll be talking about mapping market share with Tableau and open data. And then once they're both finished, we'll see how much time there is. I, together with a couple of others on the call, were at the Tableau conference last week. So depending on the time, I have a few slides just talking about the highlights. I announced the big draw on LinkedIn. So we have a, let me get that right, a backpack, a book, a bottle, a cup, and sort of a few small bits and bobs to give away. Again, if you're not part of the hub, if you just joined this meeting, just follow that link and make sure you join. I'll give it another sort of 15 minutes or so, and then I take all the members that are registered and set up the draw. If you only register for the call today and are not part of the hub, you won't necessarily be in the draw. And that's it from me for now. With that, I'll stop sharing my screen and have David come on. David.
Cool, so you should see the screen now. And
yep,
I
that
will
works.
And slideshow mode.
Very good, that works as well.
Cool. Awesome.
Over to you.
So this presentation is about how we're using Jenkins to deploy and test our Tableau workbook. So the agenda, so a little bit about me. I'll talk a little bit about our data process, the actual pipeline itself, how the deployments work, how we do automated testing, a bit of an example of the type of test script that we actually run or create for our Tableau workbooks, and then hopefully a demo of a working pipeline, and then if there's any time, some questions at the end. So about me, I'm a data risk manager at ANZ. I've worked with data for roughly 18 years, worked with loads of data stacks, Teradata, SQL Server, Oracle SAS, Python, OpenShift, you name it, I've probably used it at some point. Started software development when I was 15, using Excel and VBA. And I've worked in all sort of facets of data, including warehousing, analytics, administration, consulting, and management. And I consider myself a generalist. I'm not a specialist in any particular discipline, but you know, I have a pretty good knack of picking stuff up and being able to run with that. So in terms of our data process at ANZ, we've got like a ton of kind of data objects or elements that we kind of look after. So we've got a little bit of SAS stuff, but that's kind of dying out. Big sort of SQL Server code base, a little bit of Teradata, and Tableau workbooks. And so when I sort of came into the team was sort of manually deploying stuff to various servers, and it was very kind of labor intensive. So I was looking at, okay, well, why can't we use Jenkins to actually automatically deploy this kind of stuff to the various environments? And then it's there's much better audit trail, there's less sort of manual intervention, all that kind of good stuff. So moved all our code base into Bitbucket. So it's all centrally kind of managed and stored. Got the team into using feature branching for sort of any code changes. We use pull requests, peer reviews, and approvers for actually deploying pipelines and integrating into our code base. We also use Jenkins to actually deploy our SQL Server, Teradata, and Tableau code to various environments. We've got a series of code quality tests, and we've got automated testing in various environments so that once we deploy stuff, we can be, or once it goes through to production, we can be pretty certain that it's fit for purpose. So our developers work in small increments. So this is the top picture is kind of a pretty silly little example, but it's sort of typical of say a Tableau deployment. So we've got obviously the Tableau workbook, the TWB file. We've got a Python test script, and we've also
David.
got a JSON. Yeah,
David, I still see the agenda slide. Is that the same for everybody else?
No, I'm seeing the right slide.
Yeah. Okay.
I can see the Jenkins pipeline.
Okay, cool.
That happened to me before, Alex. You've got to.
No worries.
Yeah.
Shoot. That's all good. Anyway, so yeah, and so there's a JSON file which handles a little bit of a configuration, and the developers themselves, they actually guide their deployments through the various environments through to production. I used to, when we sort of first started out, every time someone did a deployment, I would be in there checking it and looking at it, and as time has sort of gone on and the process is bedded down, I rarely even sort of look at it now. And the developers themselves become incredibly self-sufficient at sort of managing the deployments and figuring out the problems and all that kind of good stuff. So how the deployment works. So this is a very high-level basic overview, but essentially the developer will push their Tableau workbook to the source repository in a feature branch. They will trigger a Jenkins pipeline, which basically downloads the repo, figures out the diff between their branch and main, and then uses the configuration file to basically package the Tableau workbook into a TWBX file, which gets pushed by the REST API to Tableau server. So an example of a deployment configuration is sort of seen below. So you've got the file name, which is obviously the TWB file. The display name is basically how you want it displayed on the server. And then if you want to hide any of the tabs. So we can put loads of things in there to customize and configure how the deployment actually runs. And so we could do that, and that was all good. So we deployed some stuff, and that was cool. And then we sort of came to the automated testing part of it, and basically, we asked the question, well, why do we test stuff? And basically, to find bugs as early as possible is shifting left. And really, when it boils down to it, it's good practice. It improves the quality because basically all the bad stuff is figured out in dev environments, and so by the time you get to production, all the bugs are sort of found, and that's all good. You basically have less rework because it reduces the cost of doing things over and over, and you get less production incidents. We use PyTest because it's really flexible. It can talk to everything we need to talk to. and you sort of get all the advantages of being able to code in Python and all that sort of lovely stuff. For us, we test in our sit and out environments, and that's basically any SQL Server, Teradata, or Tableau deployment itself. And testing for SQL Server and Teradata is pretty straightforward. But we really sort of had no mechanism for, apart from sort of looking at stuff, for testing Tableau, which really is the primary way a business accesses the data, at least for us. And if we sort of had that wrong, then it's kind of like, what's the point? You could do all this on the data. If the actual workbook itself is not right, then it's it's kind of rubbish. And I had a couple of instances where I built a Tableau workbook and I thought, yep, this is awesome, looks great. Showed it to the business, they loved it, we deployed it to production, and then 2 weeks later someone would say, hey, you know that number in that widget, it doesn't look quite right. And so you sort of go into the workbook and you go, oh, yep, that doesn't look quite right. And so the need for testing sort of came from that. It's okay, there's got to be a way of being able to sort of interrogate what we've deployed and make sure that the numbers actually line up with what we've got in the database, because essentially that's all Tableau is doing, is running some SQL queries, etc., etc. So after sort of a little bit of digging and reading around and etc., I found this little kind of quirk that if you stick .csv at the end of your Tableau sheet on the server, you could actually get the summary data back, well, the summary data that was being used in the visualization, you can actually return it. As you can see, the widget on the left-hand side, the average sales, and then on the right-hand side, the CSV with the actual data returned, which sort of got me thinking, was there a way we could actually ping the API, stream those values back, and then if we could do that, then we could actually test, the actual stuff that's been deployed. So with sort of that in mind, created a simple Python function, which can be called from within the test script, which once it's deployed, it pings the Tableau server with a particular sheet. Tableau server returns basically the string result of what the data is behind the sheet itself, and then the function just converts it into a simple data frame. And so once we could do that, then we could actually compare source to target, which is really cool. And so this is kind of like an example of what one of our test scripts would look like. So basically, you're pinging the server to get the results from the dashboard itself, and then you're actually querying the underlying database and going, well, and then just testing for equivalence. So do these things add up? If they do, great. That means I'm representing what is in the database. If not, then there's obviously a problem. I need to figure out why they're not the same value, or what my intention is not matching the actual execution. Because it's in Python, it gives you the ability to kind of play around with how you actually return some of the results. So in the second example, you can actually loop through. You can say, hey, these are my list of things I want to look for. I can loop through iteratively those things, and I can return those results in a list, for instance. So I can actually run 3 tests in run. It's a bit of a bad example, but you can do that sort of thing. So you're not writing 3 tests, you're actually writing 1, but you're actually testing all 3 whatevers that you're trying to test. So shall we see if it works? So I'm going to swap over now and go to my other screen. Cool. All right. So this is the pipeline itself. So I've created a dummy branch, which I can show you here. So basically what was on the screen. There's a Tableau workbook, very basic one. This is the configuration to actually deploy it, and then there's a test here as well. So I'm just going to punch in the branch itself, and we'll kick off a pipeline. So what's happening now? So in the background, new pipe. It is going to grab the repo. Once it's grabbed the repo, it's going to generate a change list, which will just be those 3 changes that actually came up. Once that happens, it's going to run some code quality tests. So in terms of SQL Server, it's looking for stuff like semicolons at the end of the SQL file or SQL statement. In terms of Tableau, it's looking for hard-coded SQL. It's making sure that the Tableau workbook has a test associated with it. So the initial kind of sniff test of the package. So that's just going to do some authentication. And so now what we have to do is, I want to deploy to sit. So it's going to keep going and deploy to sit. I can actually go into the console and I can see it actually what it's doing in the background. So it's deploying. Looks like it's looking at the Tableau workbook, and now it should actually deploy it to the server. And there we go. And now it's compiling the tests. Cool. So it's got to the out stage. That's good. So if we go into the server itself, I should be able to refresh it. And there it is. So there's the actual dashboard itself. And so all the database connections, all that kind of stuff have been taken care of. And I should be able to see a lovely, albeit very boring dashboard. So that looks all good. That's cool. So if I go back, so I'm kind of happy with that. So I'm going to deploy to the next stage. So I'm going to deploy to OAT. And again, it'll just do exactly the same thing. It'll deploy to the OAT Tableau folder. It will deploy to the OAT database, update all the connections, all that kind of good stuff. So again, we can go through. And so the bonus of all these sort of things, because when we sort of look at our environment, we've got a lot of things going on. All this deployment is kind of handled automatically. It's all in one place. It's very transparent. It's a great audit trail. And oh no, something has failed. Oh no. So it's run one of our automated tests and it said, and that hasn't passed. So that's cool. So we can go to the test results. So it looks like, the code quality, it's the average sales test. Okay, cool. So basically we said it should be, we were asserting that it was 254 and it's come back as 253. Obviously there's a bit of a problem. And if I look at the code itself, someone has very lazily or been careless and put a +1 in there. So that's cool. We can now go back and go, okay, we understand our mistake. So I'll just go back and I will change that test. Cool. So go back to my pipeline and I'll just replay that and go, yep, that's cool. Understand my mistake. And then we'll just kick it off again. And so again, it'll just go through the same process, download the repo, get all the latest changes, deploy them to the various environments, et cetera, et cetera. And what we found is that the great thing about having those automated tests is that if you make a change or you make a series of changes, you've got a great regression suite already. So any of your sort of subsequent changes that you make to your workbook, you can actually test and go, hey, has this messed anything else up? And I found that out when I made a change and actually screwed up a whole bunch of other things, and I wouldn't have known that if I hadn't had that automated testing running in the background. So again, we'll just deploy. Again, it just goes through the motions again. and redeploying to Oak, which is all good, all set even. And we sort of found that, after an initial period of getting the sort of onboarding the developers and getting them comfortable with it, initially it was quite a big mindset shift for them. But once they sort of got into the flow and got into the process of it, they sort of took to it pretty well. There was sort of an initial kind of period of a couple of months where it was all new and different. But once they got over that initial kind of period, it's been really good. And so again, redeployed it to Oat, and it'll keep going. And now it's going to test, and hopefully this time, because we fixed it, and it's passed. So that's cool. So now we've deployed to Sit and Oat. We've tested our workbook, and now we can proceed to production. So again, no more testing, and then it'll just cycle through into production. And so you've got a complete pipeline, deploys to multiple environments. You've tested your workbook. You can be pretty, and then right at the end, it will merge that code into the main branch, and you can be pretty comfortable that assuming you've got your test right, you'll deploy it to production successfully. And that's the sort of main gist of what we've been trying to do. So we haven't developed anything kind of that isn't already available. So basically there we go. So basically we're using the REST API. So the link is available there, and that's on GitHub. And for some of the connection stuff, we're using the Tableau server client. And that is the presentation. Are there any questions for me?
Sweet, thanks for that. I'll start with a question, and everybody else, if you have a question, either put it in the Q&A or in the chat, or ask afterwards. How do you determine how many tests you do? Like if you have a work dashboards, and each dashboard has a few sheets. Do you do it for each sheet dashboard? Do you use one per data source, or how do you determine that?
Yeah, so we take a risk-based approach. So basically, I mean, I've had this conversation a few times with our developers, but basically the headline numbers, there has to be some sort of testing. So what I found in sort of previous roles, if you're too prescriptive on the testing side of things and you say you must do X number of tests, people will do X number of tests, and then if anything goes wrong, it's not our fault. It's we were told to do this and blah blah. So we sort of say, okay, you do as many tests as you feel comfortable with, as long as there is some testing, but you take responsibility for that. And so by the developers taking responsibility for it, they tend to sort of and it's a no sort of blame culture, but you sort of put the onus on them to take responsibility for the amount of testing. So there isn't a prescriptive amount. It's more about what they think is necessary.
Yep. Cool. We have a question from Steve in the chat. How do the mergers handle the TWB files and any changes, I guess, in those TWB files?
Absolutely fine. Because essentially, it's basically as an XML file in the background, and so it's just looking at it. It's like comparing one XML file to another, and so it basically goes, "Yep, cool. You want to merge this? That's fine."
Cool. You in the example you showed, there was like the test was, does the KPI equal, I don't know, 254 or whatever it was. Is that like a hard-coded standard, right? Like I would assume that like the prod version with the new version, or how does that work?
Yeah, no. What it'll do is actually compare. So in our environments we have a bunch of test data essentially, and so that's it'll compare that value in the whichever environment you're in. So we can mock that data, and so again, it's like it's not necessarily you need the production data to test. It's more, are you I always bring it back to you're testing the execution against the intention. So what are you trying? So as long as you've got data that you can use to test your intention, then that should be sufficient.
Yep, cool. Sweet. Any other questions? There's a question from Artie. Do you add comments for version controlling and every redeployment? How is that?
Comments for version control. I mean, I guess the question is, do you mean in the Tableau workbook, or do you mean in the so in terms of, I mean, in terms of version control, the workbooks, no, there's nothing. Yeah, it's not like a SQL script where you have a code header or something like that. But all those sort of comments and who approved it and all that kind of stuff will be in Bitbucket. So we've actually got, so the basic rule at the moment is no pull request, no pipeline. So it's the first thing it does is check that you've got a pull request. The reason we have that is so people can feedback as soon as someone commits something. So they can look at the work and go, oh, no, I don't think this is right, or whatever. And we've had some great conversations, and it's all captured, but we've had some great conversations within the feature branches themselves about how things could be done better, or why have you done this, and blah blah. So that was really good. The second reason with Bitbucket, it actually allows you to get the list of files that are actually changing, and so we use that to manage conflicts. So generally speaking, we don't have an issue with it. It's a rarity if two people are working on the same file. We do have it with some of our schedules, but yeah, that test basically goes, hey, branch A is using this file, and so is branch B. I'm not going to run a pipeline because I don't want to screw stuff up. So you go back and sort out what's you need to go and talk to each other. So it lets you know which branch you're in conflict with, and yeah, away you go.
Cool. Thank you for that. Last chance to ask another question. Everybody's quiet. Sweet, thanks for that. I think that was the first time I've seen actually somebody do that on that level. What I've seen before was actually something, I don't know if it's more or less sophisticated, but they downloaded they used the same technique to download an image of the dashboard rather than the data.
Gotcha. Yep.
They basically pixel to pixel compared if it's the same.
That sounds complicated.
I think a bit more sort of on the, I think it was more tailored towards Tableau version upgrades, and if you deploy a new version of Tableau, does that impact the dashboard and that sort of thing?
Yeah.
So yeah, no, that's cool. If anybody has any questions, reach out to David directly.
Yeah, I'll put my email address in the chat or my LinkedIn profile. You can ask me any questions you've got.
Sweet, thanks for that. And then with that, we go down to Dunedin to. Hey, Steve.
Hey, how's it going? Cheers. Give me a second. Hopefully you're now seeing presentation mode PowerPoint.
Yes.
Awesome, thank you. Great, well, thanks very much, Alex. It's great to be able to talk to you all today about mapping market share with Tableau and open source data. My name's Steve. I've worked at MTF Finance in various roles for 10 years, currently head of data and analytics, and I became a Tableau Community Forums ambassador last year. I will make a quick plug for the forums. They're a great way to get quick help from experts like Ken Village, Jim Derner, Chris McClellan, and many others. Let me give you a little bit of background about MTS Finance before we get into the meat of the presentation. So we offer vehicle loans, personal loans, and business loans. We're Trade Me Motors' preferred finance partner, and we're the top-rated finance company on Trustpilot with a 4.9 out of 5. And whilst many finance companies are moving away from a branch presence, our whole business model really encourages that. Franchises are all locally owned, and the owner is in essence financially backing you and your loans. They're taking a punt on you. So in Auckland, we've got 12 franchises in or around, and around so dealers. It's a successful and responsible model for both our customers and our franchise owners, but it does come with some challenges, and measuring success is one of those challenges. Our existing measure of market share uses something called the Personal Properties Security Register. What that does is tells us when someone's registered an interest over an asset. So if you take out a home loan, your bank will register an interest on this register over your house, and that tells everybody they can't buy that house without first the bank being paid off. The problem with that is it doesn't tell us about personal loans because they're not secured against a vehicle or a house. It doesn't really tell us as much about business loans as we'd like, and the stats from the company's office are only at national level, so we can't really tell how we're doing in Auckland. When my team picked up this challenge, we found there was pretty limited data on competitor activity. We turned to proxies and estimates, as it's still pretty valuable to be able to see relative change. And we looked at various options. After assessing, we decided to go with population data from Stats NZ, continuing to use that Companies Office Personal Properties Security Register, and some open data from the Reserve Bank of New Zealand on sector-wide lending. We also grabbed some data on overall market activity known to our credit bureau, Centrix. And I will just give a quick hat tip to the team at Centrix under Stuart Baxter. They're a really smart and helpful group. Worth noting that we also ruled out various sources as being too manually intensive, in particular trawling competitor annual reports. I don't know about you guys, but I didn't really see me or my team spending weeks downloading PDFs of each of our competitors' annual results and trying to pick the figures out of those. A group called KPMG do a regular survey, so something called the FIPS survey, where they do exactly that. But even then, you're going through a PDF and pulling out the figures that you need. If you're in this situation and you need to get data on market size, you might also consider data aggregators and vendors. We took a look at CoreLogic, who we do work with in other ways, but in this particular case, there wasn't the data that we were after. So I'll just briefly flick through some of the data sources we've used, not in any level of detail, but in case you've never been to these sites, I'm sure most of you have, but just in case, data.gov.nz has got a heap of data, open source data from various organizations, councils, Stats NZ, various universities, various ministries. So here I've just searched for data sets to do with Auckland, and I've got over 2,000 data sets. So if you're looking for data up in the Auckland area, you may well find something useful there. Stats NZ themselves have a pretty cool site. I find it a little bit harder to navigate and search. There is that statistics by topic on the front page. For us, we ended up diving into the census section and downloading the latest formal population counts from census. We probably should be looking at population projections that are updated more regularly, but we haven't got that far. And then just a quick example of looking at the Reserve Bank of New Zealand. So they provide an awful lot of stats that you can download. This particular one we use is called the C5 or Sector Lending Stats. Most of the data sources are only available via manual download or email. So we have pretty basic manual or semi-automated mechanisms to load the data in. As a couple of examples there, the data that we get from the company's office comes through as an Excel attached to an email once a month. We can't download it from anywhere. So that comes through to our team and we just pick the one figure we need and we pop it into a stored parameter and that inserts it into the database for us. For the Reserve Bank of New Zealand data, we use a tool called SQL Spreads, which allows us to put an Excel front end on top of a database table. And the finance team just copy and paste the data from the Reserve Bank download into that spreadsheet, and then it goes into our data warehouse. The data is processed alongside our KPIs, including weekly geo-placement of customers, and the resulting tables are combined into a workbook on Tableau server. And we do allow some users to dive in further using WebEdit. Placing the customers into areas for which we have market data is pretty key. It allows us to get a regional picture, which I'll go into in a bit more detail later. But in terms of the weekly processing, we store Stats NZ areas in our database as polygons using the SQL Server geography type. and we map those to our territories. We're using the statistical area 2, or SA2, which is a level above mesh block for those familiar, and roughly equivalent to a suburb in cities. And you can see on screen there, that's just an example of SQL servers geospatial results, so just returning the polygons that we're storing from the database, and it doesn't map them very nicely, but you can see that we are storing those polygons. We then create a point from the latitude and longitude for each customer's address that we've got, and use the polygon st-intersects method to find the smallest area that that points within. Now, the reason we do that is some areas in New Zealand overlap. So, for example, Alexandra is a smaller area within the entirety of a Central Otago area. So picking the smallest one allows you to home in on where someone's lat along really is. Unfortunately, our data is pretty incomplete and messy, so we're also estimating area from some other attributes that we store. If our data was better, we'd probably be looking at Tableau spatial joins, and it was pretty cool to see that those are potentially coming in Tableau Prep soon, which I think was announced at TC23. Just a little bit more on estimating where a customer is. So hopefully we can place a customer based on a lat long. So where we've got the black dots on this picture, let's say those are the ones where we've got a lat and a long. We know exactly what small area they're in. So whether they're in the little yellow area or the darker teal areas, or if in one of the gray areas. But for some customers, we don't have that data. So let's say customer Z, all we know about is that they're in postcode 1234, which is that dashed area in this picture. What we end up doing is using the most frequent territory for that postcode. And in this case, it's territory 2, so the colored areas. That's pretty unreliable for the sub areas. You can see in this example, with 4 customers in 2 of the little sub areas there, it'd be really hard to know or pick for a customer that we only know is in postcode 1234, which small area they're in. So what we do there is we don't even try to do that. We just factor up the numbers of customers that we have placed in a small area by the percent that we were unable to place, but we know are in the territory. And that just makes sure the overall numbers reconcile. Enough about the data loading. Let's take a little bit look at the workbook. So we have 4 national level views covering each proxy for market size. Each view shows headline figures for the market size, the MTF proportion, and then the market share, which is a simple division, along with a trend over time. This first one's showing our long-standing share of vehicle lending sales using that PPSR. And by the way, just a note, the MTF data in this presentation is fake, except I have left in a small nod to the first COVID lockdown where sales took a real dip. Next up, an alternative view of vehicle lending. So this one's showing active loans rather than sales and using the data from Centrix. And the one thing I'll point out here is that this view illustrates the need to be clear on your metrics. So you'll note from the title that this is market known to Centrix. So if you've worked with a credit bureau, you'll know that not all customers use all credit bureaus. So Centrix don't have the data from all finance companies. This is the share of the market known to Centrix, not the overall market share. And again, these are fake figures. Third metric is population penetration. So how many of the usually resident population aged 20 to 64 are currently customers of NTF? And if the Centrix data on the past slide is overstating, then this view will be understating. It's the theoretical minimum because not every person aged 20 to 64 will be in the market for a loan. The final metric is the share of active personal borrowing, excluding home loans, based on Reserve Bank of New Zealand data, and this allows us to cover our new unsecured personal loan product. A brief tip or note on the headline figures, if you've ever wanted to produce those headline numbers at the top of a chart with percent change indicators, they're pretty basic views. They're just, in essence, a text mark. All the dates are on the view, and then there's a secondary table calculation filter. So we filter to just the latest date, and then we can still get the table calc for percent change. And you'll see a whole heap of indicators and text on that marks card in the edit label. and we're just basically, we've got an indicator and a value for each potential change, whether up, down, and what the value is, and that's so we can color each of those individually. But because of the complexity and the caveats around the measures, we are providing pretty detailed documentation. This really helps people to know when and how to use each measure, and I'd really encourage this, just because if you are using proxies, it is possible that your users will misunderstand when it's appropriate to use a measure and when it isn't. Some of our data sets allow us to drill into a regional level. So for each region, we show the values contributing to the 2 proxies for market share. And what you're seeing here is basically 2 columns of results. Actually, I'll skip to the next slide shortly, which has got a more zoomed in version, but you're seeing 2 metrics and then a light blue column that is the average of those. So because we've got a theoretical minimum and a theoretical maximum, we won't get every person, but Centrix won't know about every loan. We just pick a midpoint between the 2 as a very rough proxy for what market share probably is. And to allow us to see where we're winning here, we're using a hex map. And that's because some of our regions have a pretty small area, so they get lost if you just plot an overall map of New Zealand. If we look at it in a little bit more detail, in this fake data, you can see that we seem to be doing well in Central Otago on the hex map down to the bottom left. And you can select that area to see the trend over time in the top right. And you might notice some drops in the figures there. The Centrix data here is actually largely unfake, and a new finance company came on board with Centrix, and we haven't got the latest data from there, so the data hasn't been recut. Just to dive into the hex maps, how we've created those, it's a very simple grid behind the scenes with an X or Y for placing the hexagons. So as you'll see here on the highlighted, it's an XY coordinate and then a hexagon shape that we've loaded in as a custom palette. And we blend onto the main data source there for the measure and detail to show, which in this case we did because the measure is in a previously built data model. And then you've got a size to suit with this approach, otherwise the borders between look a bit rough. For the last 2 views, I'll show you users can also drill into a region. That's to allow them to get further insight into the impact of local area marketing. So are the mobile billboards in the right place? Are they doing the right leaflet drops? Do they need to tweak their radio advertising or go to different community events like club barbecues, that sort of thing? Users can drill into a region to see the population penetration by statistical area too. Or they can drill in via postcode to see the market known to our credit bureau Centrix. And here you can see in this fake data, something is working particularly well around the Wellington airport area. So we'd be asking ourselves the question, what can we do to replicate that elsewhere in the region? So building the maps is actually a little anticlimactic given the title of this talk. They're very basic maps as we have the polygon in the data set. So as you can see here, all we've really had to do is put polygon on detail and then put measure onto color to provide the heat map. In summary, measuring market share can be really hard, particularly sizing the overall market. If you find the same, do consider using proxies or estimates. It will likely still be valuable to your organization because they can see relative change over time. You can work with partners or find other data sources, such as from data.gov.nz, but please do take the time to understand, document, and probably over-explain your proxies and estimates. It's really important your users understand and remember any caveats. Do map your data if it helps your users to identify patterns, and consider hex or tile maps if your areas are quite variable in size. And just finally, I'm happy to answer any questions, or you're also welcome to drop me a line later.
Very good, thank you. Same as before, if you have any questions, just either unmute yourself and ask, or ask a question in the chat or the QA. While you think about that, do you know, like, do you have a rough idea how accurate those calculations are? Like, do you know how what market share Centrix represents, and sort of how close you are to what you think might be the real market share?
Yeah, great question. It gets quite complicated. My gut feel is that anytime we've tried to do a blended calc, it's actually not ended up far off. But I'm a bit worried that I don't compare apples with apples there. So market share of new sales is not the same as market share of currently outstanding loans. We might be doing really great at selling over the last quarter, but also have lost a lot of customers, or we've previously done not so well. But by and large, when I've used that averaging, it's come out pretty consistent with other metrics. The challenge comes in where there are particular regions where a finance company isn't prevalent. So say in the Nelson or Tasman region in New Zealand, there's Nelson Building Society. If they don't use our credit bureau, we won't be seeing their business. So we're likely overstating our market share there.
Yep. Any other questions?
I see that there's a bit of a comment on the hex map. So I will just give everybody a freebie before we go. Bear with. So if you want to build your own hex map, you're very welcome to pop along to my personal blog, or hit me up on one of those contact details. There's a template and guide available to build some NZ hex and tile maps. So it'll give you a regional version of each of those, but it'll also take you through how I went about working out what the coordinates are for each hexagon or each tile, building those spreadsheets and then blending them with other data.
Cool. Thanks for that. I think what I did like was you can see that you have been around for a while. Like all your charts and dashboards look consistent and clean, and so that's really good to see. Sweet. With that, we have another 9 minutes left. So let me share my screen again. A couple of things from TC last week before we do the draw. Really just a few shout outs. We from Brisbane, so that was Paul Russ with the winning dashboard here, and I think the really cool thing was that he actively uses Tableau since June last year. So has been using basically Tableau for I think 6 to 8 months or so before his feeder submission was selected as one of the finalists, and that really shows sort of how much is possible if there's a personal interest for that. He also did a couple of shout outs for community project because he started with Tableau and sort of being interested in that because of community projects. And I think that's a really cool thing as well. So if anybody, I basically the bottom line is there's no excuses not to participate next year. You can win a free ticket to a Tableau conference. The winner gets 10 grand US. And I think the third one still gets $2,000 US. So even being a finalist is well worth the effort. Next up, there's recording 50. If you have been around Auckland for a while, Sam Batchelor used to work for Fonterra in Auckland. She has been to a bunch of user groups. She's now in Brisbane, but she ran the speed tipping session, which is on Salesforce Plus. And there's another, I think, 15 or so sessions from the Flurlach brothers and a couple of others, which are really sort of reach from sort of very high level conceptual to sort of nitty gritty here tips that actually can help you get better at Tableau. So that's something I would definitely recommend just checking out. And what was announced was that next year's conference will be in San Diego, which is a bit of a change from Las Vegas. And that'll, from all we've heard, be around the same time. So April, May, something around that. We've heard in the past that they wanted to stick to having Tableau conference that time of the year.